Okay, we're going to have a look at writing a function using the input and the output. Okay, so let's have a little look at our first example on question 1. What we want to think about is a function is something to do with our input x to give us our output. Now, sometimes this is called y, sometimes this is called function of x, sometimes it can be called something else. So I'm going to use function of x today to get us used to using that notation. Okay, so let's look at the x. So what we need to do is we need to look at what mathematical operation we are doing to the x to get the output. Okay, we're also going to look for the missing value. So let's have a look at these first 3 and the bottom one. We are dividing by 7. Okay, so what we're actually doing is we're doing x divided by 7, and that gives us the output. So if we're looking at this first number, we would have 35 in here, because 35 divided by 7 would give us 5. Now let's write this as function notation. So we have the function of x is the same as x divided by 7. And we really want to try to use a fraction for the divide. So our function of x, which is our input, what did we do to our input? Well, we did the input divided by 7. So you could almost say that this is our output, which we knew. Okay, so if you've understood that, why don't you pause the video and have a go at the next 2 questions. I'm going to go through the answers in just a moment, so pause it, have a go, and then play the video. Okay, I'm hoping you've had a go. If not, I'm going to go through it, and hopefully this will help. So let's have a little look at our input x. Okay, what are we doing to get the output? So what are we doing in all of these occasions? Well, we are actually multiplying by 7. So we could say x times 7. So the missing number here is going to be 2. 2 times 7 is 14. Now let's think about algebraic notation. We've got the function of x is x times 7. This is better when we write it as 7x. It's more mathematically correct and also much easier to read and use. So we're going to have 7x here. That is our function of x. Okay, let's have a look at question 3. If you haven't had a go, pause it and do the question, and then play the video and we'll do it together. So our input is x, and we look at what do we do with each of these here. It must apply to all of them. Well, actually, we are adding 16. So our missing number here is going to be 5. 5 add 16 gives us 21. Let's write the function. We can't actually simplify this one, so we're just going to keep it as the function of x equals x plus 16. That's our function. Okay, I've got 3 more questions for you. So why don't you pause the video, have a go at them, and then I will just go through the answers of all 3 of these. Okay, hopefully you've had a go at these. If not, please pause it and have a go. Let's have a look at this one. X here. Now, what are we doing in each of these occasions here? We are actually adding 20. That's x plus 20 gives us the output. So for this top one, we're going to have 25. Now let's write this as a function notation. Again, we can't simplify this, so it's x plus 20. A function of x is x plus 20. Okay, for number 5, we have x here. What are we doing to each of these numbers? We can see we are timesing by 4. And again, let's try to write this in a more high-level way. Missing number is going to be 40. Let's timesing by 4. And then the answer at the bottom is going to be f of x equals 4x. This is not mathematically incorrect. Remember that. However, when we think about our communication and having clear and concise mathematical communication, 4x is much better. Let's look at the last one. So input is x. What are we doing each time? Now the first one might be dividing, however we can see that doesn't work for the others. We're actually minusing 6. So the missing number is going to be 10. We have the function of x is going to be equal to x minus 6. So for each of these questions here, we have figured out what we do to the input to get to output, and we have created our function notation, so our function rule for this. Hope this helps.